All right, class. So I'm not making it full screen because in full screen mode, it's too hard for me to change the color. Sometimes it does let me, sometimes it doesn't. So I'm just keeping it this way. All right. So let's review the action potential one more time. On the x-axis, we see time in milliseconds. On the y-axis, we see the membrane potential in millivolts. Resting membrane potential for neurons, specifically for neurons, is at minus 70 millivolts, and minus 55 millivolts is the threshold. Meaning, if the membrane potential changes from resting state to threshold, which is minus 55, there will be an action potential. Okay, so few things. So from resting membrane potential to threshold, we see graded potential. And when we talk about graded potentials, which channel is mainly responsible for graded potential? It is ligand-gated sodium channels. The ligand-gated sodium channels are the primary ones that help to create the graded potential. Remember, the graded potential takes place on the soma and dendrites. That's where the graded potential takes place. What else? Which other channels are open which other channels play a role to increase the membrane potential from resting state to threshold? Obviously, the leak channels, the sodium leak channels, the potassium leak channels, they are always open, right? And then the sodium potassium pump. So all these play a role to generate graded potential, which can or cannot lead to threshold potential. Okay, now if threshold is reached, if you reach threshold, there will be an action potential. So the green, the light blue, and then the red at the very tail end, everything represents an action potential. Okay. Now, we also talked about the phases of action potential. We have depolarization. And depolarization is when we have more and more positive charge getting into the cell. So if this is a cell, if more and more positive charge enters the cell, that is depolarization. Repolarization is when all the positive charge go out and the membrane potential is restored back to negative 70 millivolts. So that's repolarization. And then hyperpolarization is this little overshoot here. And in hyperpolarization, we have, so this is the cell, let me draw it here. We have even more negative charges. So the inside becomes more negative as compared to resting membrane potential. Okay, that's hyperpolarized state. Okay, now we will see which channels are open and which channels are closed during depolarization, repolarization, hyperpolarization. Good. So let's talk about depolarization. I'll do this in green. Okay. So depolarization. During depolarization, we have the voltage-gated sodium channels open. These channels open. How about the sodium leak channels and potassium leak channels? Obviously, they are open too. How about the sodium potassium pump? That's open as well. How about the ligand-gated sodium channels? They are closed. How about the voltage-gated potassium channels? They are closed as well. Okay, so we know which channels are open and which channels are closed during depolarization. Let's talk about repolarization now. So during repolarization, which is all this. During repolarization, what happens to the voltage-gated sodium channels? Well, they close. Remember, right here at positive 30 millivolts, the voltage-gated sodium channels close. What happens to voltage-gated potassium channels? They open at positive 30. They are open, and the voltage-gated potassium channels are responsible for repolarization. What is going on with the ligand-gated sodium channels? They are closed. How about the sodium-potassium pump? Well, they are open. How about the sodium leak channels? Open. Potassium leak channels open. Okay? Now, let's talk about hyperpolarization. During hyperpolarization, the voltage-gated sodium channels are closed. Voltage-gated potassium channels are closed. And during this time, remember, the voltage-gated sodium channels are actually resetting themselves back. We will talk about that in a bit. Now, the ligand-gated sodium channels are also closed. It is only the sodium-potassium pump and the sodium leak channel and potassium leak channel, only these three are open, and these three are responsible for bringing the membrane potential back to minus 70 or negative 70, which is resting membrane potential. All right, so let's do this one more time. Okay, let me erase all this first. রিয়ান আস্তে করো মাম্মা, আস্তে করো, আমার ভিডিও করছি, আস্তে করো প্লিজ। দিমির ঘরে যাও, এখানে আওয়াজ করো না, যাও দিমির ঘরে। তুমি দিমির ঘরে যাও। Okay, class. So, sorry about that. So let's review this one more time. From resting membrane potential to threshold, the main channel that's working is ligand-gated sodium channels. Those are the ones that are working mostly. During depolarization, the main channels that are open are voltage-gated sodium channels. As more and more sodium channels open, more and more sodium enters the cell and makes the cell makes the inside of the cell more positive or less negative. Then during repolarization, we have the voltage-gated potassium channels open, and hyperpolarization is mainly caused by the sodium-potassium pump. Okay, how about the other channels? Well, we know that the leak channels, the sodium leak channels and the potassium leak channels, the leak channels are always open. Leak channels open, leak channels open, leak channels open, leak channels open, right? They are always open. How about the sodium-potassium pump? During graded potential, the sodium-potassium pump is open. Here, the sodium-potassium pump open, sodium-potassium pump open, and it is the sodium-potassium pump that helps to restore the resting membrane potential after hyperpolarization. Now, on your exam, you might expect some critical thinking question based on what we drew. So I might ask you, okay, during depolarization, circle all the channels that are open, or during repolarization, circle all the channels that are closed. So you must know which channels are open during which phase of action potential. All right, another thing, know that the voltage gated sodium channels, they open at -55. So -55 voltage gated sodium channels open. +30, these channels close. Okay. Voltage gated potassium channels, they open at +30, they open. And know one thing, they actually close when the resting membrane potential is reached. So they close at -70. But then you can ask me, Rupa, if the voltage gated potassium channels are closed, potassium is not leaking out, so how come we get the hyperpolarized state? Well, remember, the leak channels are still open. Since the leak channels are open and a lot of potassium are leaking out, the membrane potential even drops further and we reach the hyperpolarized state.
Mama,
Sorry, class. Yes. Rian, you have to go upstairs and go to bed. You have to sleep now. Okay? Go.
I'm going to be like the bender.
Right here. Okay. Oh, no. Okay, yeah, take it, go. All right, sorry about that, class. It's so hard. Okay, so that was my mini lecture on action potential. The key point is you must know which channels are open and which channels are closed at which phase of the action potential. All right. So I'll stop here and then